In place of conventional gears, a CVT transmits power by means of two pulleys and a steel belt that runs between them. One pulley receives the torque generated by the engine, and the other pulley transmits drive torque to the tires. The gear ratio is continuously varied by changing the width of the pulleys. In this way, seamless gear ratio changes are achieved from low speed to high speed. This graph compares the power transmission performance of an automatic transmission and the CVT. With an automatic transmission, ratio changes are accomplished by gears, resulting in drive torque losses when the transmission shifts. And because gear ratio changes are made in a step-like manner, shift shock also occurs. By contrast, a CVT varies the gear ratio continuously. Since there's no drive torque loss or any shift shock, it improves fuel economy and provides smooth, powerful driving performance. Its smooth, seamless power delivery effectively brings out the engine power. These superb qualities make the CVT a truly ideal transmission. Nissan has already equipped with March and a Cube with the CVT, which has highly been acclaimed by customer. Today's CVT is being used in many vehicles, not only by Japanese automakers, but also by European vehicle manufacturers. Yet, despite being taunted as ideal transmission, the CVT has still one shortcoming. The amount of drive torque it can transmit is limited, because it is constructed such that a steel belt is squeezed between the faces of the two pulleys. Until recently, a 1.6-liter engine was considered an upper limit for CVT application. Nissan has now overcome that barrier by applying its unique cutting-edge technologies to develop the Hyper CVT, the world's first CVT capable of handling the high torque generated by the 2-liter class engine. In order to transmit the large torque produced by a 2-liter class engine reliably, higher pressure must be applied to the pulleys that squeeze the steel belt. It also requires a belt with sufficiently high durability to withstand the increased pulley pressure. For the Hyper CVT, Nissan developed a new oil pump, capable of generating a higher hydraulic pressure, and the new high-pressure hydraulic control system featuring improved accuracy. The control system applies high hydraulic pressure to squeeze the belt reliably when large torque has to be transmitted, and reduces the squeezing force to transmit less torque. This accurate hydraulic control avoids wasteful use of energy. As a result, the Hyper CVT is able to provide high reliability, along with improved fuel economy. To achieve greater durability, Nissan adopted a high-strength steel belt that is wider than the conventional belt. Moreover, a torque converter that locks up at low vehicle speed has also been adopted. These advanced technologies produce a host of benefits. This includes smooth, seamless driving performance, powerful acceleration with ample power in reserve, and a 20% improvement in fuel economy over that of a vehicle fitted with a conventional automatic transmission. The adoption of a torque converter provides ample creep capability, make it easier to start up on uphill slopes and to put the vehicle in the garage. Automatic engine braking has also been achieved. On downhill slopes, optimal engine braking is applied at all times according to the vehicle speed and road grade. This allows the driver to keep the transmission on the drive position while traveling downhill without any need for frequent shifting or braking. And, for added driving pleasure, a 6-speed manual shift mode is also available. A 20% improvement in fuel economy, combined with smooth, powerful driving performance. This is among the outstanding features of the Hyper CVT, an ideal transmission developed by Nissan.